Somewhere in your house right now, there's a monthly bill for the privilege of talking to the internet. A router you don't own the software on, a modem that answers to a company, and a cable running back to infrastructure you have zero control over. Now imagine cutting that cable and still being able to send a message across town, across the mountains, or across a disaster zone where every cell tower just went dark, with hardware that costs less than a dinner out, running software nobody can shut off because nobody owns it. That's not a thought experiment anymore. People are actually doing this right now in 2026, and today I'm going to show you exactly how. Welcome back to the channel where we map the wars, the weapons, and the power struggles shaping our world, one falling domino at a time. Today's domino is a quiet one. No missiles, no battlefields. Just the slow, unglamorous collapse of the idea that you need a corporation between you and the person you're trying to talk to. Let's get into it. First, the homework, because this is the concept that makes everything else make sense. Your phone already knows how to talk to the world, but only through one narrow door. The legacy telecom stack, cell towers, fiber backbones, companies with shareholders and billing departments standing between every word you send and the person receiving it. That's the internet, you know. But there's a second, quieter layer of connectivity that's been growing for years in parallel. Bluetooth mesh, LoRa radio, packet radio, satellite links, networks that don't need permission, don't send you a bill, and in most cases don't even need the internet to function. Individually, none of them can replace your home broadband. But stitched together, they become something else entirely. A network of networks, a super mesh that routes around whatever's broken and uses whatever path happens to be available. That stitching is the whole trick, and it's what turns a hobbyist radio project into something you could genuinely call your own ISP. The tool doing most of that stitching is a project called Reticulum, an open, cryptographically complete networking stack built to run over almost any medium that can push ones and zeros. Instead of relying on IP addresses tied to fixed infrastructure, Reticulum uses cryptographic destinations, meaning a message finds its way to the right recipient no matter what physical network it travels across. LoRa, Wi-Fi, packet radio, even a tunnel through the ordinary internet. It's free, open source, and permissionless in the same spirit as early Web3 promises, minus the token speculation. Think of it less as an app and more as a replacement layer for what TCP/IP does for the regular internet, except nobody's in the middle collecting rent. For the last few years, this stayed a project for radio enthusiasts willing to solder their own boards. That's changing fast. Developers building on Reticulum filled 2 full sessions at FOSDEM in Brussels back in February 2026, and the community effort since then has focused squarely on closing the gap that always held the project back. The documentation, the friction, the fact that using it required you to already be an expert. The current shipping release, RNS 1.3.9, landed in July 2026. And notably, Mark Kvist, the developer who originally created Reticulum, stepped back from public involvement in December 2025, which, instead of killing the project, seems to have pushed the wider community to take more ownership of where it goes next. That's usually a healthy sign for an open protocol, not a worrying one. So here's the real question. If you actually want to try this, what do you need and where do you start? Step 1 is understanding that you have options, and they're not all the same tool. Meshtastic is the easiest on-ramp. Flash cheap firmware onto an ESP32 board with a low-raw radio, and you've got a node that can text nearby devices without cell service or Wi-Fi using a pre-shared key for encryption. It's polished, it's got the biggest hardware ecosystem, and it's genuinely plug and play, which is exactly why it became the default choice for hikers, preppers, and event organizers who just want messages to work. Its weakness shows up at scale. Meshtastic floods messages across every node and range hoping they arrive, which works beautifully for a campground and starts to choke once you're trying to cover a city. MeshCore is the newer alternative built to fix exactly that problem. Structured routing through specific device paths instead of blind flooding, plus delivery confirmations, which makes it a better fit if you're trying to build something more like real public infrastructure rather than a weekend gadget. And then there's Reticulum, which isn't really competing in the same category at all. It's not optimized to be the easiest app to open. It's optimized to be the most capable stack to build on top of. It uses proper modern cryptography, ED25519 signatures, and X25519 key exchange, generating fresh ephemeral keys every time 2 nodes connect. That means, even if someone records months of your encrypted radio traffic and later physically seizes a device to pull out its keys, your past messages stay unreadable. Reticulum packets don't even carry source addresses, so an eavesdropper can see a packet is heading somewhere, but not who sent it. If Meshtastic is the friendly starter home, Reticulum is closer to owning the land the house sits on. Here's the honest trade-off, though, and it matters if you're picking your first project. Reticulum's biggest weakness has always been standalone hardware. For a long time, it needed a full computer or Raspberry Pi running the stack, with a connected radio acting only as a dumb modem. Not ideal if you want a solar-powered node sitting unattended on a hill for months. That's exactly the gap. A newer piece of the ecosystem, micro-reticulum, is closing. A lightweight implementation of the reticulum protocol that runs directly on a microcontroller, no full computer required. It turns a $20 board into a standalone relay that can extend your mesh without anyone babysitting it, which is the difference between a demo and actual infrastructure. Step 2. Once you understand the landscape, is picking your entry point based on what you actually want to build. If you want to talk to friends off-grid with the least friction, grab a couple of Meshtastic flashed boards and you'll be messaging within the hour. That's the appeal that's pulled so many people in as hardware costs have collapsed, with capable LoRa boards now selling for less than a restaurant meal. If you want to build actual public-facing infrastructure, something other people can connect to, route through, and depend on, that's where Reticulum earns the extra weekend it takes to understand. That public infrastructure piece is really the heart of becoming your own ISP, because a private mesh in your backyard is a toy, and a mesh that strangers can discover and route through is a network. The way you do that with Reticulum is by standing up what's called a transport node, a piece of infrastructure with a public address that anyone running a compatible client can connect to over ordinary Wi-Fi, LTE, or 5G, and from there get bridged out onto LoRa, packet radio, or whatever else that node happens to support. You can run one on a cheap cloud instance, on a Raspberry Pi at home, or on a dedicated field unit. And once it's running, it shows up on public maps of the network, the same way early internet exchange points once showed up as literal dots on a map of who was connected to whom. There's a real irony worth sitting with here. A lot of these no company controls this transport nodes end up hosted on Google Cloud, AWS, or similar centralized infrastructure, because that's the cheapest way to get a stable public address. That's not a failure of the concept. It's actually the whole point of how Reticulum is designed. It doesn't require you to burn the legacy internet down before you can start. It uses whatever infrastructure already exists as scaffolding, and as more LoRa links, packet radio stations, and satellite bridges fill in the gaps around that scaffolding, the network gradually becomes less dependent on any single company's servers to function. You're not replacing the internet overnight. You're building a parallel structure that can, piece by piece, route around it. Step 3 is the part most people skip, and it's the part that actually matters if your goal is resilience rather than a fun weekend project. Bridging your mesh to something that has zero conventional connectivity at all. This is where a field bridge comes in. A unit running two interfaces at once, say a satellite uplink like Starlink on one side and a LoRa radio on the other, so a message can arrive from the ordinary internet and leave entirely over radio. Add an offline device on the far end. A phone with cellular, Wi-Fi, and Bluetooth all switched off. Its only link a USB-connected LoRa radio, and you've built a working, if narrow, bridge between the internet-connected world and a device that has no internet connection whatsoever. That's the actual test of whether any of this works, not whether two laptops on the same Wi-Fi network can chat, but whether a message can leave the conventional internet completely and still arrive somewhere. And this is where line of sight becomes your real enemy. LoRa is remarkable for its range on tiny amounts of power, but it's fundamentally a radio line of sight technology. Trees, hills, and buildings will cut your range down from miles to a few hundred feet fast. The fix people are experimenting with right now is elevation, mounting a lightweight standalone relay node. Thanks to micro-reticulum, this no longer needs a full computer, just a microcontroller and a radio, onto something that can get above the tree line. A tower, a rooftop, or, for genuinely dedicated builders, a drone hovering as a temporary relay. It sounds almost silly until you remember that the alternative is leasing space on a commercial cell tower, which typically runs a multi-$1,000 installation fee plus a multi-year contract, an ongoing rent, or launching your own CubeSat, which starts in the tens of thousands of dollars even at the cheap end. A $20 board on a pole, or briefly on a drone, solves the same elevation problem for the cost of a takeout order. Step 4, and this is the one that separates a hobby node from something that functions like real infrastructure: security. The moment you expose a public transport node to the internet, you've opened a door anyone can walk through, and that includes people who want to abuse your bandwidth, your compute, or your cloud bill. Anyone who's had a cloud account compromised and woken up to dozens of virtual machines silently burning through GPU credits overnight understands exactly why this matters. The practical fix is boring but essential. Lock the node down to only the ports and services it actually needs, keep it isolated from anything sensitive on the same network, and treat it the way you'd treat any other piece of public-facing infrastructure, because that's exactly what it now is. And it's worth being honest about the one thing none of this fixes on its own: the long haul. In most real-world builds right now, the middle of the journey, the part connecting your local mesh to the wider network, still quietly rides on conventional infrastructure somewhere, whether that's a cloud-hosted transport node or a satellite uplink. LoRa is brilliant at solving the last mile once you're off-grid, but it's not yet a practical substitute for the backbone that gets a message from one side of a country to the other. That's the frontier a lot of builders are actively chipping away at now. More elevated relays, better antenna setups, and eventually orbital or long-haul radio links that don't depend on a company's fiber at all. It's not solved yet, but 3 years ago, none of this existed outside a handful of radio labs, and today you can buy the hardware on a whim. That trajectory is the actual headline here. Step 5 is remembering the point of all of this. It has to work for someone who isn't you. A network only a radio enthusiast can operate isn't really an alternative to the internet. It's a hobby with extra steps. The real test of any of these projects is handing a normal client app and a single address to someone with zero technical background and seeing if they can send and receive a message without help. Newer Android clients built on top of Reticulum have started closing that gap, connecting over TCP, Wi-Fi, Bluetooth, or a dedicated radio node, and looking and feeling like an ordinary messaging app rather than a command line tool. That gap between works for engineers and works for everyone is, honestly, the single biggest thing standing between this technology and actual mainstream relevance. Every serious builder in this space right now is racing to close it, and it's closing faster than most people outside the community realize. So what does actually becoming your own ISP look like? Boiled down to something you could start this weekend? Pick your entry point. Meshtastic if you want something working today. Reticulum if you want to build something others can connect to. Get 2 or 3 cheap LoRa boards flashed and talking to each other in your own house first. Once that works, stand up a public node somewhere with a stable address, even a free tier cloud instance, and let it show up on the wider map. Then start pushing your range, elevation, better antennas, a second relay, until you can hold a connection somewhere your phone's regular signal can't reach. None of this requires a license in most jurisdictions because the low-raw bands these projects use are unlicensed ISM spectrum with defined power limits, the same rules hobbyists have used for weather balloons and remote sensors for years. You're not asking permission, you're just building. Here's why this matters beyond the novelty of texting your friend with no cell signal. Every layer of infrastructure you don't own is a layer someone else can throttle, meter, monitor, or simply switch off during a disaster, a blackout, a border closure, or just a bad month for your provider's stock price. A mesh you built yourself, running protocols. Nobody can revoke your access to, doesn't have that failure mode. It's slower than fiber and it's not replacing your Netflix connection anytime soon. But the day the towers go quiet and the fiber's cut, the difference between a working mesh node in your closet and a dead router isn't a technicality. It's the whole point. So that's the real shape of becoming your own ISP in 2026. Not one company you switch to, but a stack of small, cheap, unglamorous decisions that add up to owning your own path off the grid. Tell me in the comments whether you'd actually run one of these nodes yourself, or whether this stays firmly in prepper hobbyist territory for you. I rate everyone. Like the video if this made the concept click, subscribe if you want the next domino before the headlines catch up, and I'll see you in the next one.